So let us see on how we can be able to understand about what we call the vector projection. So a way the projection as it will be used in this lesson, it will just have to simply means a shadow. So a vector projection, it is the same as calling it as the shadow of the vector. Let's say we have an object. Let's say this is the object, and it is vertically oriented, and there is a light here which is beaming onto the object. Let's say that is the case. Now this object will possess a shadow down, horizontally, with actually horizontal to the ground. So this is the object and this is the shadow. So the shadow itself, it is the projection of the object. So a projection or simply means a shadow. Let's say we have a vector, I'll call it as vector A. And let's say we have another vector, and from the same point, let's say this is a vector B. And let's say the angle between the two vectors is given as angle theta. And let's say this is a point P in which the two vectors are emanating from. And this is, let's say, R, and let's say this is Q. I'd say so. Then let's think of having the line vertically down from Q to some point along or within the line PR, or within the line of the vector R. Actually should be within the line of a vector A. And let's say this is some point M. That is. Should be, let's say this is a point A. Now, if we think of beaming this vector B with a light, so the shadow of the shadow of this vector B will appear within the line of a vector A. So the shadow of the vector B will appear within the line of action of a vector A. And for the sake of interest, let's say this is the shadow in which, let's say this is the shadow in which the vector B will produce within the line of action of vector A. Now, as you can see, I'm expressing the shadow as a vector. So I'm expressing the shadow as a vector. And we have choice. We can express the shadow as a vector, or we can express the shadow as the magnitude. But what is happening here is that as we are beaming this actually a vector B, the shadow of the vector B will appear within the line of action of a vector A. So the shadow itself can be expressed as a vector, or can also be expressed as, how to say, the scalar value or magnitude. So now, in this case, since the shadow has been expressed as a vector, then this is the projection. This is a projection of vector B onto vector A. That is, if the shadow is being expressed as a vector. And how can we have that? or C. Then if the shadow is to be expressed as a scalar value or in terms of a magnitude, then we have the component, that is a comp of a vector B, comp of a vector B and onto vector. In other words, if the shadow is to be expressed as the scalar value or the magnitude, it is just simple. It is just simply means this is the x component of the vector B upon being resolved. And this is what we are going to observe. If this is to be the x component of the vector B, then that will be given as this, using what we call the trigonometric ratios. This is adjacent and this is hypotenuse. And you observe that we'll have the x component. Let me go it as, let's say we'll have it as a cos theta is equal to adjacent, which is PM, and divided by hypotenuse, that is magnitude of the vector B, of which you observe that actually the PM, which is the component of the vector B, will now be given as vector B magnitude times cos theta. So where cos theta is the angle between the two vectors. So which means the component of a vector B in the line of action or in the vector A will now be given as vector B magnitude times cos theta. So this is how it will be if we are to express the shadow itself as the scalar value or even as a magnitude. But now, what is the basis of all this as well? How should we have the scalar projection of vector B onto a vector A as it stands here? Now, that is how you should have to understand. Let's say you should have to understand that the angle between the two vectors using the dot product, which is this one, can be given as cos theta, and which is equal to dot product of the two vectors divided by the magnitude divided by the product of their magnitudes. So magnitude of vector A times the magnitude of the vector B, of course. Then let's do cross multiplication. You'll see that we'll have the dot product of the vector A as well as the B, and which is equal to, we'll have multiplication of, let's have this, let me have it here. We'll have the dot product of the two vectors, and which is equal to now magnitude of a vector A times the magnitude of a vector B and the times cos theta. And of which this is how you can observe it as. You see that this part of the equation here corresponds to scalar projection of a vector B onto vector A, as you can see. Now what would that be like? Now we'll have it as vector A dot vector B, and being given as vector A. Let me have it in this way, being given as divided by magnitude of vector A, and which is equal to magnitude of vector B times cos theta. And this is the same as this, and of which it is the same as this, and therefore the scalar projection of a vector B onto vector A now therefore the scalar projection of a vector B onto vector A, just simply being given as dot product of the two vectors and divide by magnitude of a vector A. So keep that in mind. So this is how we are going to calculate that. And how about the vector projection of B onto A? Now that one will simply be calculated as, we're going to multiply this one by the unit vector of a vector A. So in that case we'll have it as vector A dot vector B divided by magnitude of a vector A, and the times the unit vector of a vector A will be given as a vector A and divided by the magnitude of a vector A, and of which this is the same as having it as the vector projection of B onto A, just been given as, so we'll have it as a vector A dot vector B divided by, we'll multiply these actually in magnitudes, so that is the same as magnitude of a vector A and that to the power 2 times vector A. So this is how the vector projection will be calculated. So if we are to express the shadow in terms of a magnitude or the scalar value, this is how we'll have it. But in terms of the vector itself, this is how we're going to have it. Now how can you look at this? Well, let's say if we have the scalar vector the scalar projection, which is given as a comp, let's say comp M onto N. Let's say we have this. Now the formula will say we'll have vector M dot vector N divided by the magnitude of a vector N. Let's say if we're looking at the vector projection, now vector projection of M onto N, that will be given as, vector M dot vector N divided by the magnitude of the vector N to the power 2. Always what is here? Always this one becomes the numerator, and the times that is a vector N. So you need to familiarize yourselves with the arrangements of the parameters there, I should say the vectors. Let's say if we have, let's say, a scalar projection of, let's say, vector 2 onto 1. Now the formula will be given as 1.2 divided by 1 square time, actually should be just that. And how about the vector projection? We'll have it as we'll have it as 2 onto 1, and which is equal to 1.2 divided by 1 divided by, so he just have to with not 2 there, that is that magnitude of 1. And while vector projection will have magnitude 1 to the power 2 times that is 1. So you should have to understand that one. And let's say if we are looking for, let's say, scalar projection of x onto y, this is the same as x dot y divided by that 1 onto 2 becomes the numerator, that is that. And in terms of the projection, I should say the vector projection of x onto y, then we'll have it as x dot y divided by y magnitude square times vector y. So this is how the formula can be manipulated, but that is how you have to understand about the analysis of the vector projection. So it is just a typical shadow of a vector that you can have. Let's say we have a vector u, and which is given as 2i minus 2j and plus, let's say, 2k. And let's say we have another vector v, which is given as, let's say, 5i plus 2, let's say, plus 2j minus, let's say, 2k. Let's say that is the case. Now, what is the scalar projection of a vector v onto u? What is the scalar projection of vector v onto u? So that is a component, should be a comp of v onto u. And what would be that? We'll have it as a v dot actually u divided by the magnitude of the vector u. And how about the vector projection, given as the projection of v onto u? What would be that? So simply have it as the vector v dot vector u divided by the magnitude of the vector u to the power 2 the times a vector u. And this is how we're going to calculate those things. So let's see on how we're going to make use of these formulas. So let's start with the scalar projection of the vector v onto u, but just have to familiarize yourselves with the formula itself, how we can twist the things. Don't memorize, but just have to understand how it works there. So let's start with the scalar projection, and according to the way the formula is, we'll have to start with the dot product of the two vectors, that is vector u dot vector v. So what is that? We'll have 2 times 5, that is given as 10, and the negative 2 times positive 2, that is negative 4, and also here negative 4. And what will be there? We'll have it as 2. Then what is the magnitude of the vector u? So that will be given as the square root of, and we have it as a 4 and a plus 4 and a plus 4. That is the same as the square root of, should be given as 12. So that is the magnitude of the vector u. That is the magnitude of the vector u. We'll have it as a square root of 12. That is, then we'll substitute into this formula. and that corresponds to have it as 2 divided by square root of 12. And using sides, you can simplify this. That will be given as 2 divided by 2 square root of 3. That is the same as that. And of course, we'll have 2 there. We'll have it as 1 over square root of 3. Or else we can have this as a decimal number. So that is what you call the scalar projection of a vector v onto U. Now how about the vector projection? What would be that? Well, on the vector projection, we'll have it as a projection of v onto U. That is the same as, we know it is given as vector v dot vector u divided by the magnitude of vector u to the power 2 times a vector actually u. So in this case we have the dot product that is being given as 2. You divide by, then what is the magnitude of a vector u that we have calculated? We have it as square root of 12. Now what is that to the power 2? And the times what is the vector u? We have it as 2u, actually 2I, minus 2j plus 2k. That is what we have. Mind you, the brackets I'm using here, they are open brackets because the vector has been expressed in terms of unity vector notation, which is portraying enough information there. And now for this case, we'll have it as 2 divided by this square, and also this square will cancel, have 2 over 12, and that is 2i minus 2j and plus 2k. We'll have that. This is the same as having it as 1 over 6, and then we'll distribute 1 over 6, so multiply here, multiply here, multiply here, component true. That is how it will be. That is how you can have it there. So that's how you should have to understand about the vector projection and also scalar projection of a vector. Let's say we have a vector m, which is given as, let's say, in a component form 2, 5, 4. And now we have a vector n that is given as -1, 0, let's say 2. Now, what is the scalar vector projection? I should say, what is the scalar projection of m onto U? What is scalar projection of m? Should be of m onto any. That is, we are looking for the scalar vector, actually for the scalar projection that is of m onto n. What would be that? And also vector projection of the same case. What would be that? So try to have that at your own time, and also try this one as well. What if, let's say, we have a vector a, and which is given as, let's say, cos pi over 2 I, let's say, minus cos pi over 4 j, and the plus, let's say, cos, and let's say pi over 3 k. And we have a vector b that is have been given as sine pi, let's say over 3, should be over 3, and the plus, let's say sine, I should say sine pi should be j, and the plus, let's say cos of, let's say 2 pi k. So what is the scalar projection, I should say scalar projection of B onto A, and also the vector projection of B onto A as well? Try to have this. Thank you.